This next lesson is solving linear inequalities. So the first thing we're going to do is consider this inequality, x is less than 1. Off the top of my head, I thought that x could be 0 or -5, but there's lots and lots of values that are less than 1. So the graph looks like this. Notice how we have an open hole at 1, and then we go to the left. So all these numbers are less than 1. Notice how it's an open hole? That means I get as close to 1 as possible. So, for example, 0.99999 is still less than 1. So that's a mathematical way to indicate that I'm getting close to 1. But when I hit 1, it's not part of the solution. And the solution is written in set notation. X with a slash, x is less than 1, which is read the set of all real numbers x such that x is less than 1. And we have to get our tuxedos on for that one because it's a really formal way of stating the solution. Next, we're going to consider an inequality that looks like this, which is called a compound inequality. Two values for x that could make it true are 0 and -2. And the graph looks like -3 to 1. I have a solid circle at -3 because I have an equal to there. I want -3 to be part of the solution. An open hole at 1 because I don't want 1 to be part of the solution. I want x strictly less than 1. And then writing the solution set in notation, x with a slash and the compound inequality, which is read the set of all real numbers x such that x is greater than or equal to -3 but less than 1. That's why I love math. This whole thing with that big sentence. Now, how to solve them, okay? The only catch is this. You do it exactly the same as you solve the equation, but when you multiply or divide by a negative number, the direction of the inequality sign must be reversed. So here we go. So I'm going to write my inequality. I'm going to subtract 3 from both sides, just like natural. Realizing I have a -1 in front of the x, I'm going to divide both sides by -1. But that will reverse my inequality sign. Now why? Well, on a number line, if I think about it, 1 is less than 2. But what happens when I do -1, -2, which is the equivalent of multiplying or dividing both of these by -1? Ooh, -1 becomes greater. So see how that works. I'm going to erase that so that you will not get confused with the graph. And here we go. Let's graph. Do we want -6? Yes, we do, because it has an equal to. So greater than or equal to, less than or equal to, you do a solid dot. Solid. Greater than or less than, it's open. Cool? So we're going to do a solid dot at -6, and we want x to be greater than it. So we're going to go to the right, to the right. Done. Next. Okay, now we're going to solve 2 more inequalities on this slide. So the first thing we're going to do is distribute this 6 through. So it'll be 12 minus 6y is greater than or equal to 12. Now I'm going to subtract 12 from both sides. And I get -6y is greater than or equal to 0. Don't panic. I'm going to divide by -6, but when I divide by a negative number, the sense of the inequality changes, so it'll flip around. So y is less than or equal to 0. So we're going to fill in a solid hole at 0 because we want to include 0, and then go to the left because we want it smaller than 0. Perfect. Let's do the next one. Yeah, let's. So we're going to distribute through here on both of these. So we'll get 2x minus 6 is greater than 1. Now, be careful here when you distribute the negative 3, it becomes negative 3x, but a positive 15 here. So now we're going to combine like terms on a side, so I get 16 take away 3x, 2x take away 6. So now what I'm going to do is I'm going to add 3x to both sides, you guys, because I don't really want to have to deal with the negatives. So we get 5x minus 6 is greater than 16. Add 6 to both sides. So I'll get 5x is greater than 22. Sorry, misspoke. Now what we're going to do is divide by 5. So x is greater than 22 over 5, which is really 5 goes into 22 4 times with 2 left over, so 4 2/5. So if I'm going to put that on a number line, it'll be right about here, and I want it to be an open hole at 4 2/5. And I want it greater than, so I'm going to go off to the right. Now, let's do the compound inequality. Yeah, let's. So this really means that this expression, 2x plus 1, is greater than negative 3, yet less than or equal to 7. It's like a soap opera. So I'm going to subtract 1, but I'm really solving two inequalities at the same time. So I'm going to get 2x is less than or equal to 6, yet greater than negative 4. And I'm lucky. Why am I lucky? Because 2 is positive in front of the x, so I don't have to worry about the inequality signs being reversed. So I'm going to divide everything by 2, because I'm solving two things at once. So negative 2 is less than x, which is less than or equal to 3. Now we just have to do set builder notation, which is wicked easy. Good. And now we graph. Open hole at negative 2, closed hole at 3, and then we fill it in between. Done. And of course, we have to have a little mini application in here because they're so fun. A student scored 74, 80, 94 on 3 algebra tests. What must he score on the 4th test in order to have an average grade of at least an 85? At least means I want to be greater than or equal to 85. So how do we average things? Let x equal the score on last test. The 4th test. You know what I'm saying. Well, if we're going to average them, we have 74 plus 80 plus 94 plus the stinking x value, and I'm going to divide it by 4. We add them up. We divide by however many numbers there are. Perfect. So I'm going to use my little handy-dandy calculator so I don't mess up. 74 plus 80 plus 94 is 248 plus x over 4 is greater than or equal to 85. Well, what do we do with the 4? We clear the fraction, so we multiply both sides by 4. Well, these 4s will divide out. Yay! So 248 plus x is greater than or equal to, let's do 85 times 4 is 340. I'm going to subtract 248. 248, I don't need to switch the inequality. I'm not multiplying or dividing by a negative number. I'm just subtracting. And I get a 92. Is he going to get an 85 or above? Maybe if he really studies. Okay, now, of course we have to write a little happy statement. So he must score at least 92 on the fourth test. And then we put a little smiley because we're really psyched because we don't have to use set builder notation on this. And now you'll be able to do this assignment. Good luck. This one will be like, phew, take care. Bye.